Well, folks, how are we keeping? You're very welcome to Thursday's Leaving Cert Geography class. Today we're finishing off soils and the biome, but we still have to look at plants and animals as well. Okay, so far we've looked at location and climate, and we're nearly finished soils. We're going to finish off soils today. Just be aware, guys, in for Friday, so tomorrow, we will have a live class. It'll be at 12:30 to coincide with when we usually have class, and in that, guys, I'm going to give you a part of an essay to do for the weekend, and in that class we're going to go through how to structure that essay and what to include. Okay, but for today, so you should be watching this video on Thursday. To start off this class, we have 5 short revision questions there, guys. Some of them are literally one-word answers, so I want you to pause the video and spend a couple minutes answering those questions. When you're ready, hit play, and we'll do the corrections together. Okay, so corrections. Okay, so question one: what latitude are deserts located at? Some of you actually got this wrong when you were sending me your answers there in the last couple of days. So latitude: what latitude can deserts be found at? They can be found 15 to 30 degrees north and south of the equator. Okay, so literally just either side of the equator. Question two: what name is given to desert soils? What name is given to desert soils? Aridosols. Okay, aridosols. Arid meaning dry and infertile, and sols referring to soil. Aridosols. Okay. Question three: what name is given for the daily temperature range? Okay, so deserts, they have a high daily temperature range. What's the name given to this? It's the diurnal temperature range. So deserts can have a diurnal temperature range to about 40, even sometimes to 50 degrees Celsius. Okay, it can be like -10 at nighttime. It can be 30 or 40 degrees during the day. Okay. Question four: how much rain does the desert receive annually? So on average, how much rain do deserts receive annually? It is between 0 and 500 millimeters of rain. Okay, usually probably around 200 millimeters annually. Okay. Why do desert soils lack water and humus? So desert soils have potential, but the reason why they cannot support growth is because they're lacking water and they're lacking humus. Okay, so they lack water because of a lack of rainfall, and they lack humus because of a lack of vegetation. So in Ireland, the soil has loads of humus, and this humus comes from dead plant litter. So when trees lose their leaves, when plants die, those bits of plants decompose to form humus, which is really good, or it's plant litter, which is really good for the soil. Okay, in the desert, there's very, very little rainfall. Why is there very little rainfall? Well, we'll go through this now. Okay, so deserts have very little rainfall. Reason number one: a lot of deserts are under the influence of they're beside cold ocean currents. Okay, and a cold ocean current will mean that the air coming in above the on top of the ocean as it comes in to land over deserts, that air does not have ability to hold moisture. Cold air cannot hold moisture. So when that cold air reaches the desert, okay, it'll get heated up, but it has no moisture in it, so it will not bring any rainfall. Okay, so cold air coming from a cold ocean current will not have any moisture, hence when it reaches deserts, it will not bring rain. Reason number two: a lot of deserts are in the rain shadow. So the deserts are in the rain shadows of mountains. So when air, okay, so say you have some air with moisture and it comes in and it meets a mountain, it must rise above the mountain to get over it. Okay, when it rises, the air cools, and we know cold air cannot hold moisture, so it'll rain. It'll lose its moisture in the form of rain. Then by the time that air reaches deserts, okay, the air has lost all its moisture. An example of that is the Gobi Desert in the Himalayas. The Gobi Desert is located in a rain shadow, the rain shadow of the Himalayan mountains. Okay, reason number three is deserts don't have lakes and rivers. Okay, because there's no lakes and rivers, there is no evaporation. Deserts are very hot, but if there's, it's a bit like turning on the kettle with no water in it. Okay, yeah, the kettle will get hot, but there's going to be no evaporation, no water cycle because there's no lakes and rivers or anything like that. Okay, so moving on to our final few bits of soils. Okay, so soils in the desert biome. Okay, so basins in the desert, okay, have deep soils, okay, from lots of weathering of the surrounding mountains and rocks. So soils in the desert are quite deep, okay. So lots of weathering of surrounding mountains and rocks. What's the main form of weathering in the desert, exfoliation, onion weathering. It gets extremely hot in the day, extremely cold at night. This causes rock to expand and contract over time. Layers of rock literally peel off. Okay, you can kind of see, if you look, this is desert soil here, you can see the bits of rock that make it up. Okay, desert soils do not retain water well. There's lots of evaporation. Lots of evaporation leads to minerals such as calcite, sodium, and gypsum being brought to the surface by capillary action. So, because why is there lots of evaporation? Why is there lots of evaporation? There's lots of evaporation because of the heat. But we know there's not a lot of water to evaporate. There's no lakes or rivers. So instead of evaporating water, okay, vital minerals, calcite, sodium, and gypsum get brought to the surface by something called capillary action, okay? And these are vital minerals that the soil needs, okay? And all these minerals get brought into the surface into one place, and this is a problem, okay? This leaves the soil alkaline. Alkaline basically means, you might have heard that term in biology, it makes the soil have a really high pH, okay? So quite a high pH, and the soil structure as a result is poor, and this is bad for growth. Okay, why is this? Because all these minerals should be evenly spread out in the soil. Instead, they all exist up near the surface. Okay, and this makes the surface alkaline. Okay, another thing happens called calcification. So calcification, another thing that dominates the soil process. So when all these minerals go to the surface, they can form a calcite rich layer of hard pan. Okay, so a calcite rich layer. So this here is your calcite rich layer, guys. Okay, all the minerals have washed to the surface here, and it through evaporation, and this layer is basically almost impermeable. That means water and minerals and nutrients cannot really pass through this. So for example, you look at the plants up here, right? The plants up here, the deeper you go in soil, I suppose the greater chance you have of finding the water table. There's water very deep underground. These plants cannot access the water table that's really deep because of this impermeable layer called a calcite layer. Okay, this makes soil very alkaline and does not allow vegetation to grow, as we can see. Okay, so to recap on that, guys, we know soils are very deep. Okay, we know unfortunately, so there's lots of heat in the desert, which should cause evaporation. Because there's no water to evaporate, what evaporates instead? Minerals evaporate instead. So those minerals, calcite, sodium, and gypsum, they all get brought to the surface. Okay, what's the problem with this? It leaves the soil alkaline. Which means it got a high pH, and it is bad for growth. Okay, all these soils being brought to the surface can form, and something can happen, can cause something called calcification. What's calcification? A hard calcite layer that's basically impermeable exists in the upper layers of soil. What does this mean? It means trees and plants cannot access the water table. So the water table is often deep underground, and trees cannot access this because there is a impermeable calcite layer. Okay, so another thing that's very evident in desert soils is salinization. Okay, salinization. This basically means that soil becomes toxic. Okay, because all the minerals have been washed to the top. Okay, it's a bit like, for example, one of the big minerals is sodium, which sodium is just salt. Okay, so sodium, the soil becomes toxic because so much sodium has basically been pushed to the top of the soil. Okay, and that's called salinization. Okay, it's a bit like if you put salt, if you put, a bit of salt is fine on your food, but if you put loads of salt on your food, it'll become toxic. It will not be nice to eat. Okay, high levels of evaporation. Again, what causes this, guys? Evaporation. So all these minerals going to the surface, gypsum, sodium, that's caused by evaporation. Okay, they get evaporated because of the intense heat, and this brings dissolved salts or sodium to the surface, which we know is called salinization. Something called salt pans get formed on the surface, and these are made of calcium and sodium, which is salt. So if you look at the picture here, guys, you can see big rolling hills in the background. They look like, I suppose, sand. When you look here, you can see a white layer. That is literally a layer of salt called a salt pan. Okay, and the problem with that salt pan is it makes the soil toxic and infertile. Okay, so sometimes salts need to be broken up to farm. So if you're a farmer in this region and you want to farm this area, okay, you would have to literally go with a shovel, back-breaking work, and that's a really hard layer, okay? That salt pan. You would literally have to dig that salt pan up with your shovel and I suppose clear a space to farm on, okay? In fact, some local people in deserts, they actually break up this salt and they grind it down and they sell this salt to people. They sell this salt commercially, okay? So to recap, guys, the first thing we looked at was we looked at soils, okay, and how they have lots of evaporation. And this evaporation there's no water to evaporate. So what gets evaporated instead? Minerals, gypsum, salt, calcium. They get evaporated to near the surface or onto the surface. And when they go near the surface, they can form, calcification can happen. Okay, what happens here? An impermeable layer forms that basically means the plant roots cannot access the water table. Okay, another big thing that happens is salinization. What is salinization? Salinization is when sodium, too much salt, gets brought to the Earth's surface. What happens? A salt pan like this can form. Okay, a salt pan. All right, what does this mean? Well, you cannot farm. Like, look at the trees here; they're dead. Okay, you cannot farm or grow any plants in an area that has a salt pan. The soil becomes alkaline. It's got a high pH, and the soil is extremely infertile. Okay, so to farm this area, local people have to literally break up the salt. This would be very hard. This would be like a layer of ice. They have to break up the salt with spades and shovels, and then they have to clear a space that they can farm on. Also, sometimes they actually sell this salt commercially because there's so much of it. Okay, um, good stuff. So, guys, you got 6 revision questions here to do. Okay, it's not necessary. You don't have to take down the notes. I can send you on a PowerPoint on Friday. But there are 6 revision questions I want you to do. I want you to upload those to Schoolwise. If Schoolwise isn't working, you can send me an email. Okay, with your answers on it, guys. Again, we've a live class on Friday at 12:30. I'll send you a link out to that, and you see, yeah, same as last time. Click on the link and you're in. We're going to plan a bit of an essay in that class, and that essay then is to be done for your homework over the weekend. Okay, folks, thanks very much for tuning in, and look forward to chatting to you on Friday. Take care.